Hello, everyone. I hope that you guys can hear me. And I hope that you can see my code editor. Yes, you can. Perfect. Awesome, awesome. Paramveer is asking, what language are we going to choose to study object-oriented programming? Now, as you guys might already be familiar with it, there are tons and tons of languages that support object-oriented programming, right? However, there is a de facto language when we come to object-oriented programming. I'm getting a lot of suggestions over here. Someone is saying C++, someone is saying Python, right? But unfortunately, fortunately or unfortunately, the de facto language when it comes to object-oriented programming is Java. All right. So no, I'm not getting towards C. Utkarsh, C does not support object-oriented programming. Okay, so we are going to work with Java. Okay, but the concepts that we study will apply to other languages as well. So if you're coming from a C++ background, if you're coming from a Python background, perhaps a C# background, you will be able to still understand the concepts. All right, cool. And once again, we won't be strictly going over other languages, but if you have questions about a language, X language, let's say, okay, Pragya, can you tell me how does encapsulation work in Python, or how does such and such work in such and such language? Okay, if you have questions like this, please feel free to ask me. Okay, fair enough. Cool. Soumya is saying, are you using Emacs? No, Soumya. So I am using Sublime Text. So I'm currently using this editor called Sublime Text. So I'm not sure if you can see this about window. Can you guys see this about window that I'm moving around? No, you cannot? Okay. Cool. So I'm currently on Sublime Text version 4. Sublime Text version 4. Okay, that is what I'm on, what I'm using. Now, for this session, there is no constraint of any sort of editor or any sort of thing. You can just sit back and you can watch this session. But I highly recommend you that you take notes. Okay, highly recommend that you take notes. Now, once again, whatever we will be writing in this sheet today, right? Whatever we'll be writing in this document today, all of that will be available to you via the Discord and Telegram channels. Okay, the notes will be shared. Fair enough. Cool. Mohammed is asking, in which category this masterclass would come? I mean, is it basic, intermediate, or advanced? So this masterclass, you can categorize it as a basic masterclass, right? So this is basic concepts of object-oriented programming, right? All the concepts that you might have heard of, like inheritance, encapsulation, generalization, abstraction, right? What is runtime polymorphism? All those things we will be looking at. All right. Cool. Perfect. Kumar Ankur is saying, I am learning C++. Should I switch to Java? So this is also a very common question. So let me quickly address this at the beginning itself. That I work in language X. Should I switch to language Y? Okay. And the answer is varied. Right? So if you are just beginning, right? If you're just beginning with your career, then yes, please switch to Java. Because working with Java will give you the most bang for the buck, right? If you look at the amount of jobs, right? So, I mean, there's a common saying that J in Java, right? So the J in Java and JavaScript stands for jobs. Okay. Now, this is not true, but yeah, this is a common saying. So yes. Apart from that, if you are already comfortable with some language, if you are already comfortable with language X, right? There is no need to switch. Fair enough. Cool. How long will this session be for? So once again, some logistics. This session it's currently 8:08. So this session is starting from 8 p.m. and it will go all the way till 11 p.m. In the mid, we will have a break. All right. Okay, so that is some logistics. Sanjay is saying, please, can you make your screen white? Guys, are you having problems seeing this? Is the font size large enough? Is the color scheme okay? It is okay. So, Sanjay, unfortunately, I mean, I could convert it into a light theme, but 90% of the programmers, they feel comfortable with a dark theme. So, unfortunately, I won't be able to satisfy that. We can totally make the font a little larger. Okay. Is this comfortable? Yes, cool. Now, we have another question like, will design patterns be covered? Right? Design patterns be covered? The answer is will be covered. The answer is no. For design patterns, we have separate master classes. Right? So if you go to the Scalers event page, sooner or later we will have a master class on design patterns as well. In today's class, we are going to look at the basics of object-oriented programming. We are going to reinvent it from scratch. So we will not have the time to go over design patterns. Right? Similarly, so what we will not cover, let me take this. What will we not cover today? We won't cover design patterns. Okay, we won't cover things like ER diagram or how to design a solution, right? We will not cover low-level design, right? Machine coding. All these things, they will not be covered in today's class because these are large topics, right? Similarly, solid principles will not be covered in today's class, unfortunately. So these are topics that deserve their own masterclass, and we regularly have masterclasses on these topics. All right. So if you are looking for additional material on these, if you want to learn these things, then please go to the scaler.com/events page, scaler.com/events, and you will be able to find the masterclasses over there. Okay. Perfect. All right. Is this for beginners? Yes, Ankit. This masterclass is for beginners. If you are already familiar with object-oriented programming, I will still suggest that you can stay back because we are going to reinvent object-oriented programming from the scratch today. So it might be the case that you have some misconceptions. We can get them clear today. All right. Object-oriented programming is also part of low-level design, right? Yes, object-oriented programming is a low-level design, is a part of low-level design, but low-level design is a very, very broad category. So I just put that umbrella term over here that we are not going to cover all the details of everything. Okay, we are going to focus on object-oriented programming. Perfect. It's already 8:11 in my clock, and more than 700 people have joined. So I guess we can begin the class. All right. Perfect. Let's begin the session. So first of all, let's talk about something called programming paradigms. Okay. Programming paradigms are basically a style. Okay, a style of programming. So what do we mean by a paradigm? A paradigm is kind of a culture or a style of doing something, and programming paradigm relates to a style of programming. Okay. Now there are many different styles of programming that you might have encountered. Right? So can someone help me list down the different programming paradigms that they have heard of? What are the commonly used programming paradigms? So the basic thing that pretty much everyone has done is called procedural programming. Yes. What do we mean by procedural programming? In procedural programming, something like C, right, or something like COBOL, right? What we do is we go step by step. We have a bunch of code, something like assembly language. Yes. We have a bunch of code. We execute the code one line at a time. Okay, that's exactly what we do from top to bottom. That is what procedural programming is. Fair enough. So examples of procedural programming languages would be languages like C, right? Languages like assembly, languages like COBOL, and so on and so forth. All right. Apart from that, what other things have you heard of? Functional programming, definitely. Okay. So in functional programming, we are very heavy on functions, on pure functions specifically. Right? There's things like lazy evaluation. There is things like monads and functors and all sorts of weird things. Okay. Apart from that, yes, what have we heard of? We have heard of declarative programming. Cool. Declarative programming. Can someone give me an example of declarative programming? Or what does declarative programming really mean? Yes, Ankur has a nice example. SQL. Same says Aditi and Utkarsh as well. So basically in declarative programming, we don't really tell the computer how to do stuff. Right? In declarative programming, we'll simply tell the computer, hey, this is what I want you to do. Go figure it out for yourself. Okay, this is not machine learning. This is not machine learning. In machine learning, also the computer figures out something on their own. Right? In declarative programming, something like SQL or something like HTML. Right? When you're creating an HTML page, you don't tell the computer, okay, this is how you actually draw these elements. You simply say that, okay, I want a div over here. I want a button over here. And the computer, the browser has to figure out how to do that. Okay, that is declarative programming. You declare what you want. Okay, apart from that, we have event-driven, okay, or reactive programming. Fair enough. Concurrent programming is not exactly a programming paradigm. Okay, it's not exactly a style of programming. You can say that, okay, it's kind of a style, but usually we don't put concurrent programming over here. Other than that, they are data driven. Yes. You might have heard of aspect oriented. There's tons and tons of programming styles. Okay, so we are not going to go over all of these. One of the very important programming, one of the most important programming paradigms, which we are going to cover today, is something called object-oriented programming. All right. Yes. Now, I mean, there's just one thing. I mean, something that grinds my gears. So when people talk about object-oriented programming, they usually call it OOPS. Right? There is no S in object-oriented programming. Okay, so please don't call it OOPS. It's OOP, object-oriented programming. Okay. Cool. Right. So this is what these are what programming paradigms are. Each programming paradigm has its own pros and cons. So let's quickly see which one is the best of these. Okay. So let me quickly launch a quiz. Let's see the answer for this particular question. So you have 30 seconds to answer this quiz. 25 seconds remaining. Only 130 out of 760 people have answered the quiz. So I would strongly recommend that you quickly, move quickly and answer the quiz. 10 more seconds to go. So around 30% of the people have still not answered the quiz, which is kind of surprising. Cool. So we got a 50-50 almost split in object-oriented, and there is no single best programming paradigm. The correct answer over here is, as you can guess, there is no best programming paradigm, right? Whenever you talk about computer science or whenever you talk about anything, right? Usually that is the case, that there is no perfect thing. Yes, nothing is perfect. Each programming paradigm has its own pros and cons. Okay, just like that, object-oriented programming also has its own pros and cons. There are a lot of advantages, but there are some disadvantages as well, right? And there are people who specifically work with things like data-driven programming, right? Or people who are specifically very concerned about speed, right? The speed of execution of a program. They perhaps do not like object-oriented programming that much. Fair enough. So, for example, if you're creating some sort of a game, right, very very graphics heavy game, or if you're creating some sort of thing like a high frequency training algorithm, right, then you will not prefer object-oriented programming because it has some overhead. Fair enough. Cool. Perfect. Now, in reality, in practical life, most popular programming languages that you encounter. Okay, there's a specific term that we use for these programming languages, and the term is that these are multi-paradigm languages. Fair enough. So if you have heard of languages like C++, Python, Java, Ruby, right? All these languages, JavaScript, they do not just support one paradigm, they support multiple paradigms. Right? So things like JavaScript, right? Python, Java, Ruby, C++. What other languages have you worked with? Kotlin, okay. PHP, all right. So all these things, they support multiple paradigms. They support procedural, they support functional, they support event-driven, right? They support object-oriented. Okay. All of these languages, they support all of these things. Let me quickly turn on the word wrap. Okay. Now there are some other languages like Rust or languages like Go, right, which have varying degrees of all these things. Right, so Go does not perfectly support object-oriented programming. Similarly, Rust does not perfectly support object-oriented programming. Fair enough. So most of the languages that we encounter, because every paradigm has its pros and cons, it's not that you have to learn only one paradigm. Learning object-oriented programming makes you master of everything. That is not the case. Right? You have to understand, you have to appreciate all these different things. Okay. Today we are going to focus on object-oriented programming. Fair enough. Cool. Perfect. All right. So before we begin, let me quickly introduce myself. Pretty much every one of you already knows my name, right? So this is kind of a late introduction, but hey, I am Pragya, right? And if you want to reach out to me, you can ping me on LinkedIn. So I'll just paste my link over here in the chat as well. If you guys want to reach out to me, you can ping me on LinkedIn, and we can have a chat. If you want personalized guidance, if you want to ask some questions, feel free to reach out to me. Okay. I have quite a lot of programming experience, not as a professional per se, but I started programming when I was back in class 5th. All right. So yes, I mean, I have quite a lot of programming experience. Programming is kind of my passion, right? I program on a daily basis. All right. Abhishek is saying, will we be getting a recording of this video? And what about the notes? So Abhishek, we have already covered that. Recording of this video will not be available unless you are a student of SCALER Academy. So if you are a student, then it will be available. SCALER student. Okay. And whatever notes we are taking over here, so whatever I'm writing over here, this will be available to you in a nice PDF format. So I'm currently writing in some syntax called Markdown. Right? If you're familiar with GitHub readmes or other things. So this is the Markdown thing. So what I'm going to do is I'm just going to render it. So this will, let me just preview the Markdown. Just give me a second. So it will look something like this. So notes will be available to you in this kind of format. Okay, so I'm writing this in Markdown format, but after the session is over, we will make the notes available. All right. Cool. Hey, Deepak. Is the college open? Is MIT open right now? Yes, cool. Okay, so let's begin. Let's begin with these things. So in object-oriented programming, this programming paradigm tries to relate things, right? Tries to relate things with real life. In real life, when we think about anything or when we solve problems, how do we go about it? First of all, we establish some conventions. Yes, we establish some facts, right? We establish some concepts, right? There's something called a concept. We establish these concepts. These concepts have certain things, right? These concepts have certain things. Then we reason about these concepts. Right? We figure out how these interact. We figure out how these behave, right? What their properties are. We talk about all these things for our concepts. Yes. And once we have a large repository, once we have an understanding of a lot of different concepts, then we try to use those concepts to solve problems. Do you guys agree? This is what we do in real life. Yes. Object-oriented programming tries to mimic this in code. Okay, it tries to mimic this in code. So first of all, let's introduce what a concept is. Okay, let's quickly talk about what a concept is. So a concept is basically some idea, some abstract idea. Okay, a concept is basically some abstract idea. An abstract idea could be something like the concept of a bird. Okay, a bird is a concept. What do you know about a bird? When I say a bird to you, some mental picture comes into your mind. Yes. What is that mental picture? A bird perhaps sitting on a tree branch. Yes, it has a beak, it has some feathers, all those things. Yes, so when you think about this concept, you're thinking about a few different things. You're thinking about the attributes of the bird. Right? So what is the color? What is the shape of the bird? What is the weight of the bird? What is the species of the bird? Yes, a lot of different things like this. You are talking about the behavior of the bird. The bird chirps. Yes, the bird can fly. The bird can peck. The bird can eat. Yes, things like that. You're talking about attributes. Yes, you're talking about you're talking about relationships with other concepts. Right. So we also have a concept called a tree. Yes, we also have a concept called a tree. We also have a concept called a worm. So you might want to say that, okay, a bird sits on a tree. Yes or no, guys? Right. So, guys, if you're having trouble, if you're facing trouble with video or audio, then please reload the page. Right. So if you guys are facing that trouble, please reload the page. Yes. Cool. So is this idea of a concept clear? Is this idea of a concept clear? Now, a bird is just a concept, right? A bird is just an abstract idea. It does not really reflect anything in real life. Okay. For example, when I talk about a pen is an abstract idea, right? When I talk about this pencil, this Apple pencil, now this is not an abstract idea. This is something that physically exists in reality. Yes or no? Concepts don't physically exist. physically exist. Right? They're just ideas. Does that make sense? So this is what concepts are. On the other hand, we have something called objects. Right? And objects are real life things. Real life things. They exist physically. Right? These are something that you can touch and feel and interact with. Does that make sense? So a bird is a concept. That bird sitting on that tree branch, right, which is just about to fly, that bird, that particular bird is an object. Yes or no? So is the distinction between classes versus, concepts versus objects clear? Its concepts are just the ideas, objects are the real life things. Okay. Now, one thing that is interesting to note is that whenever you have a concept, whenever you have an object, each object ties to one or more concepts. Yes or no? Whenever you have an object, it will relate itself to one or more concepts. For example, when I'm talking about this Apple Pencil, I can talk about the concept of pencils. I can talk about the concept of digital pencils. I can talk about the concept of electronic devices. Yes, I can talk about the concept of Apple products. There's a lot of different concepts that I can relate this to. This is the object. Yes, and I can relate this to a lot of different concepts. Fair enough? Yes, cool. So just a quick pause over here. Some people are complaining that there is some sound problem. So are you guys able to clearly hear me, or is my sound not clear? It is clear. Okay. So once again, if you're facing some issues with the sound, then try to adjust your headphones, try to reload the page, and perhaps that will fix it. So is Abhishek is saying the video sucks. Is this text not visible clearly? Is the resolution too low on your side? That is also clear, it seems. Okay. So once again, if it is not clear, then please try to increase there might be a setting thing, right? So please try to increase the resolution from 480p to 720p or higher. Okay. Cool. So is this clear, the difference between concepts and objects? Yes. Cool. Now in object-oriented programming, we basically mimic these in programming concepts. Yes, we mimic these in programming. So basically, when we have a concept in real life, this is analogous to a class in code. Fair enough. So if we are describing a board, if we want to describe the concept of board in code, we will do that by creating a class. Right? So I'm using Java code over here. So I'll say something like class board. Okay, and then I'll open some sort of a block over here. Does that make sense? Yes. So basically, classes are concepts or ideas. Yes. Now, as we said, that in real life, whenever we talk about an idea, we talk about the attributes, the behavior, the relationships. Okay, we talk about the attributes, the behavior, and the relationships. So just like that, when we describe this board, we can provide some attributes. We can say that the board has some attributes. Attributes. Okay. What attributes can a board have? What attributes can a board have? It can perhaps have an int or let's say double age. Okay. Perhaps it can have a double weight. Perhaps a board has a name, right? So it can have a string name. Yes, it could have a string species. Yes, it could have a color, right? A bunch of other things. Yes, these are all attributes of the board. Does that make sense? These are the properties of a board. Okay. Now, Shrikant, there is not much difference between a property or attribute. Right? Properties and attributes from a conceptual level, they're the same thing. However, in different programming languages, for example, in a programming language like Python, right, there's a different meaning of what an attribute is and what a property is. Okay, conceptually they are the same thing. Okay, but I mean, if you want to talk about what exactly a property is, let's pause that question till we discuss the encapsulation part. When we come to the encapsulation part, we'll talk about what properties in Python are. Okay. Yes. Cool. Perfect. All right. Now, apart from these attributes, a bird can have relationships with other concepts. So don't you agree that birds have wings? Yes, birds have wings. Now, these all different things that I said over here, right? These are attributes that I told you over here. These are primitive concepts, right? Or basically primitive data types. Yes, it is very easy to understand something like a double or something like a string or something like a color, right? But when I talk about a wing, the programming language does not really support any sort of data type called a wing. Yes or no? So basically, if I want to talk about wings, I should also create a concept called a wing. Yes, wing is also a concept. Yes or no? Now, in real life, we see that these are the attributes of the bird, and this bird has relationships with other concepts. So, I mean, a bird can have wings, right? We have a relationship that bird has wings. In programming, when we come to programming, the relationships, the has a relationship. I mean, let me come over here and we say has a relationships with other concepts. They are also defined via attributes. Okay, they are also defined via attributes. So if I want to specify that a bird has wings, what I will simply say is that bird object contains a wing object, right? Let's say something like left wing and something like right wing. Does that make sense? Yes, no? Perfect. Similarly, perhaps a bird is sitting on a tree, right, or on a branch. Right? So if I want to define a class, if I want to define a concept called tree branch, then I can say that the bird might be sitting on a tree branch. So tree branch currently sitting on something like this. Does that make sense? Yes, no? Perfect. Now I have a question from Suraj. Suraj is asking, this syntax that I'm writing, is this for Java or is this for C++? So this will definitely work in Java, but if you switch it to C++, I mean, this will still work in C++. Okay, C++ and Java, they have very similar syntax for these things. Fair enough? So pretty much all the object-oriented programming languages, you will be able to use a similar syntax like this. Okay. Saikat is saying, what about color? Color also seems like a custom object. So that depends on your programming language. Currently, we are assuming that color is something that the programming language provides for us. But if it does not provide, then we might also define our own concept called a color. Fair enough? Cool. Perfect. Perfect. Now, I have some questions about the syntax. So Anirban is asking, is a comma required at the end of a class? So perhaps after this, do I need a semicolon? Right? Do I need a semicolon? Now that depends a lot from language to language. Okay. So in something like Java, no, a semicolon over here does not make sense. In a language like C++, it might make sense. Okay. So we are not going to talk about syntax over here. Okay. So there is something called syntax and semantics. Right? Semantics is the meaning and syntax is how you write things. Yes. So we are not going to discuss about the syntax today because every programming language has a different syntax. Knowing the syntax is important, kind of. If you want to be productive, if you want to be efficient, knowing the syntax is good. But the syntax, usually your editor, your compiler, your IDE will take care of that. As programmers, we are not typists, right? Programmers are not typists. Like if you're a programmer, you are a thinker. Okay? And as a thinker, you should be more concerned about the meaning part. Fair enough. So syntax, while it is important, we are not going to be covering the syntax right now. If you want to learn the syntax, you can go online and you can read more about the syntax for specific languages. So you can look at Java syntax for object-oriented programming. You can look at C++ syntax for object-oriented programming, and so on and so forth. Fair enough. Cool. So is this idea of how do we model concepts in code? Is this clear? Whenever we have a concept, we will model that as a class. Yes. Perfect. Perfect. Now, how many concepts do we have in real life? How many concepts do we have in real life? We have infinite concepts, right? We have infinite amount of concepts, right? So let's suppose that I am trying to create, let's say that I'm trying to create a program. So a program to manage a zoo. Okay. Now related to a zoo, I can think of all sorts of concepts, right? I can think of bird, I can think of animal, I can think of mammal, right? I can think of any organism, right? I can think of food, I can think of cage, I can think of audience, I can think of entertainment, right? I can think of animal rights, I can think of security, all right? So I can think of climate, definitely, right? So there's tons and tons of concepts. There's tons and tons of concepts that I can think about when I'm trying to write a program to manage a zoo. Right? All these concepts, they are somehow related to a zoo. When I'm creating some code, will I be creating a class for all these concepts? Will I be creating a class for all these concepts? I will not be doing that. Right? I will not be doing that. I will limit myself. I will limit my code to the concepts it will use. Concepts it will use to accomplish its task. Okay. For example, if I'm trying to create a program to manage a zoo, right, then that program will have some requirements. It will not do everything in the wood. Right? It will say that, okay, this program is to manage the eating times. Right? When do we feed a particular animal? That is what this program is going to help us manage. Right? So in that case, I might want to define things like food. I might want to define things like animal. I might want to define things like time. I might want to define things like climate and security. But other things like entertainment, animal rights, perhaps audience, right? Perhaps organism, right? All these I won't have to define. Does that make sense? Yes. So there's infinite concepts in real life. That does not mean that you have to write a class for each of them. Okay. And what exactly do you create a class for? That will come with practice. Okay. That is also covered in low-level design. So getting a problem, breaking it down into concepts, right? Breaking it down into individual concepts, and then converting that into code, that is a very essential skill that you have to understand. And we cover that in a lot of depth in low-level design classes. Fair enough? Cool. All right. Perfect. So this is what a concept is. Concepts map to classes. Now let's talk about objects. Let's talk about objects. So let's come over here. Let's talk about objects. So we just saw that concepts or ideas, they map to class in programming. What do objects map to? What do objects map to in programming? For objects, there is something called objects itself. Right? For objects, the term that we use in programming is literally object. Okay? So objects in real life, right? Or physical items in real life, or objects in real life, they map to something called objects in programming languages. So let's take an example. Let's suppose that we have this class bird, and this class bird has a bunch of stuff in it. Right? So let me just copy this once again. Look at this. Okay, let's copy this perhaps. All right. What I can do is I can create an object of this class. So I can say bird B, right, equals to new bird, something like this. Okay. And this B is an object of the concept or type bird. Does this make sense? Yes. Rujata is saying object is an example of a class. No, that is not the notation that we use. We say that B, basically object, are instances of classes. Okay, that's the keyword we use. Objects are instance of a class. Okay? So when I talk about a class, when I say that we have a bird class, this bird class is simply defining some sort of a blueprint. It is simply defining an idea or a blueprint or a concept. Right? A bird is nothing concrete in itself. Fair enough. If I want to talk about a specific bird, if I want to say, okay, that bird over there, for that, I will have to create an object of that bird class. Fair enough, guys? Yes. Objects and instances, they have the same meaning. Yes. Every instance is an object, and every object is an instance of some class. Fair enough? Cool. Now, Prakash is saying car is a concept, BMW is an instance. That's not correct. That's not correct. Car is a concept. BMW, cars, right, is also a concept. It's a lower level concept. Yes, exactly. As Xavier is saying, hey, Charles Xavier, that's an interesting name. Are you from X-Men? So BMW cars is also a concept. That BMW that is parked right across the street, right? That particular BMW that is parked right across the street, that particular BMW is an object. Does that make sense? That, yes, exactly. Your car that is in your garage, that is an object. Does that make sense? Yes. All right. What are instances? Instances simply mean a real life thing, a real life instance, okay, of something. That's what we mean by instance. Something that you can touch and feel. Fair enough. Tapan is saying, can we say that objects are implementations of classes? No, no, no. Tapan, objects are not implementations of classes. This is the implementation of the class. This is the implementation of the class. Objects are simply instances of the class. Okay. Cool. Perfect. Now let's come back to this classes thing. Let's come back to this classes thing. So in the class, we talked about how classes can have attributes. Right? We can have attributes. We talked about the has a relationships. Right? All these are modeled using attributes, using variables. What about behavior? What about behavior of a class or behavior of a concept? I know that a bird can fly. Right? I know that a bird can eat. I know that a bird can sleep. So those behavior, to model those behavior, I will be writing something called methods over here. Right? Behaviors are modeled by methods. Right? So I will come and say over here that bird has a method called void fly. And inside this void fly, perhaps I am doing something like print flap wings. Does that make sense? Perhaps I can have a void eat. Right? I can take a food inside this. And I can say print consuming food item. Does that make sense? Yes. Cool. Now I have a couple of questions over here. So Adarsh is asking, what is void? So Adarsh, void is a return type. Okay, void is a return type. This is a data type. So void is a data type that holds only one value. Okay, so we are not going to be discussing return types and all those things over here. If you are not familiar with things like what is a void or what is a function, okay, if you're not familiar with these things, then I would strongly recommend that you go ahead and learn these things before coming to this class. Fair enough. So this is a beginner class, but this is not going to cater to the absolute basics of programming. For that, we have other videos on YouTube that you can go and watch to learn those things. All right. Cool. Aman is saying, is this related to def in Python? So not exactly. In Python, if you want to create a method, in Python, so let me just use the Python syntax now. If you have a class code, you will say something like, you will have a def fly self, right? And you will say print flap wings, something like this. So it might seem, on the surface, it might seem that def is something like void. That is not the case. Def is simply a keyword that we are using, while void is a return type. Okay, def is a keyword, while void is a return type. If I really want to specify void in Python, I will say that this returns none. Okay, this is the way. This is the way I would specify that this returns void. Right? Void is same as none in Python. Fair enough. Cool. So far, so good. Any more doubts so far? Cool. Akhil is saying, so can we say that objects are servants for a class? Not exactly, Akhil. Objects are not servants for a class. Objects are the instances of a class. A class is just an abstract concept. A class is just a concept. An object is a real life thing that encapsulates, that has that concept. Does that make sense? So person is a concept. You are an object. Okay, it's very bad to classify people as objects, but in reality, people are objects. Right? Every person is an object, and the concept that the person ties to is a mammal, a human, an organism, right? An earthling. All these are concepts that you are an object of. Does it make sense? Not exactly implementation, an instance. Fair enough. Cool. A lot of different questions over there. All right. So is this clear how we model behavior? Now, a common question that comes, and this is also a very, very common interview question. Okay, this is a very, very common interview question. The question is, what is the difference between a method and a function? Who can tell me what is the difference between a method and a function? So notice that when I said a class bird has behavior, I say that this behavior is modeled using methods. I did not say function, but clearly I have written a function over here. Yes or no? Clearly I have written a function over here. So yeah, what gives? I mean, I'm writing a function, I'm calling it a method. So what is the difference between a method and a function? Yes, the correct or the understanding over here is that functions are independent. Okay? What do I mean by independent? Or functions are standalone. Functions are standalone. Basically, function is something like a mathematical function. Function is anything that you given an input. It does computation, may or may not give an output. Yes, that is what a function is. Does that make sense? Yes or no? On the other hand, a method is a function that is tied to an object. Okay, a function that is tied to an object is called a method. Let's take an example. Let us suppose that we are trying to create a class. Let's say that we have a class called, let's say, number. Okay? Or let's call this bank account. Okay. In this bank account class, I have a bunch of things. So I have things like some attributes. So in this, I can have a, let's say, double amount. Okay. I can have a string holder name, right? I can have, let's say, perhaps a string account number, right? Something like this. Okay, I can have some behavior as well over here. So I can say a void, let's say, deposit, or let's say double amount. If I want to deposit some amount into this bank, what I want to do is I want to take this amount that the person is just depositing, right? And I want to somehow save this in this bank amount. Yes or no? I want to somehow save this in the bank account. So if you look at this function, if you look at this method is tied to an object of a bank account, right? When I say double amount, this function can't behave on its own. This function can't survive on its own. I will have to do something with this amount. I will specifically have to add this amount to this amount. Yes or no? Or let's say quantity. Right? I will have to do something like amount equals to quantity. Amount equals to amount plus quantity. Amount plus equals to quantity. Yes or no? Yes, this is something like I do. Now, over here, you can clearly see that this quantity is declared over here. Right? This quantity is over here in the scope. So this quantity is defined. But amount has not been defined in this function. Yes or no? Amount has not been defined in this function anywhere. Do you guys agree? Yes, where is this amount coming from? This amount is coming from the class. Right? This amount is coming from the class. So this is a function. This is not a pure function. This is a function that is tied to an object of the class. Yes, this is a function that uses this amount. Does that make sense? Yes, the following function can't work unless it knows what the amount is. Right? So it is tied to an object of the class bank account. Fair enough? Cool. Let's see how would we use this. Right? Let's see how would we use this. So if you were to write a class main, right, public static void main string args, right, something like this. Right? Throws IO exception. Right? The normal boilerplate for Java. Right? If we come over here, how will we use something like a bank account? We will say bank account. Let's say B, my account, equals to new bank account. Something like this. Okay. So this is the class name. This is the class name. This is the concept. This account will be the variable, right? And this account will be the object of this particular class. And I'm creating this object over here. Okay, I'm creating this object over here. Now, creating an object is known as instantiating. Instantiating a class means creating an object of the class. Right? So over here, what we have done is we have instantiated this bank account class. Fair enough? And for instantiating a class in Java, we use the new keyword. Now, once again, It depends on language to language. In Python, there is no new keyword. In C++, we have other things. We have constructors and destructors, right? But in Java, to create an object of a particular class, we will have to use a new keyword, and then we will have to put these parentheses around it. Okay, this is also known as calling the constructor. Okay, so basically, when we put parentheses around this, we are effectively calling the constructor. Constructor. Okay, we'll talk about what the constructor is. Fair enough. But so far, is this understood? What this bank account is and how we are using it? Okay. Now let's try to use this account. So we can say account.deposit. Let's say 100 rupees. Okay. And after this, we can try to print the account.amount. Okay. And if we do that, this should print 100. Yes. Right. If after that, if I do one more time, if I do account.deposit, let's say 1,000 rupees, if I say print account.amount, then what will this print? What will this print? This will print 1,100. Right? How is this happening? How is this happening? This is happening because when I call this function deposit, notice that whenever I'm calling this function, before the function, I'm specifying what object I'm calling this function on. Yes. So notice how I'm calling this function. I'm saying object dot function name. Yes. And then I'm passing the parameters. Yes or no? This is how I'm calling this function. Do you guys agree? So basically, when I call this function name, in this function name automatically, it will assume that it is currently working with this object, whatever object I specify over here. Does that make sense? Yes. For example, if I create a bank account, right, A1 equals to new bank account, and once again, if I create another one, if I say A2 equals to new bank account, right, if I say A1.deposit 100, and I say A2.deposit 200, if I print A1.amount, this will print 100, and if I print A2.amount, this will print 200. Right? This time around, the amounts will not get added up. Right? This time around, it will not total to 200. It will not total to 300. Because when I call this function was called on different objects. Does this make sense? What it means for a function to be tied to an object? Yes. This is what a method is. A method is a function that is tied to an object. Now, currently over here, in this deposit function, where do I see the object? Right? I mean, this A1, this A2, this account, I should be able to see this somewhere, right? Can I see this anywhere? I don't really have any A1, A2 or anything like that. Right? That is hidden inside. Right? That is hidden inside. There's a variable that is automatically provided. There's a variable that is automatically provided in any method, and that variable is called this. Fair enough? That variable is called this. So the correct way of doing this code, the correct way of writing the code would be to say this dot amount plus equals to quantity. Okay, this is the correct way. Does that make sense? So what is this? This is the current object. The current object that this function is operating on. Does that make sense? Yes, self is very similar to this. Okay, self is very similar to this. So in Python world, I would do something like this. I will have a class bank account, right? I will have a def, let's say amount equals to 0. I will have a def deposit self value, and I will say self dot amount plus equals to value. And then I will say A1 equals to bank account, A2 equals to bank account, A1 dot deposit 100, A2 dot deposit 200. Okay, this is what the Python code for that looks like. Fair enough? Cool. Now, in this particular code, in this piece of code, I could have written this dot amount. But the programming language allows me, right? The programming language allows me to omit this keyword. Right? So this is something known as syntactic sugar. Syntactic sugar is basically something that the language provides to ease your life. right? The language says that, okay, this is the correct way of writing things. But even if you don't write this, I can still figure out that you mean that this amount is what you're talking about. Yes, right? So the language provides this syntactic sugar for you. The language provides this syntactic sugar for you that you can omit writing this. All right? Python does not provide this syntactic sugar. In Python, you can't write amount plus equals to value. Right? In Python, this will give an error. Gives an error. Fair enough? Does that make sense? Yes. Cool. Perfect. Any doubts so far? Any doubts so far? All right. Cool. So is this idea of what a function is, what a method is, and if I have this missing, right? If I see a variable inside a function that is not declared in the function, where is this variable coming from? That variable is coming from the class. Okay, is that clear? Yes. Cool. Paramveer is saying, what is the advantage and disadvantage of syntactic sugar? So Paramveer, syntactic sugar is basically to ease your life. Right? And syntactic sugar is basically to basically simplify your life so that you have to write less code. Okay, the pros, the advantages are clear. The disadvantages is that now you have to learn more syntax. Right? Now you have to learn more concepts. So that's the only disadvantage. But usually syntactic sugar is good for us. Okay. Cool. Let's move on now. Let's also talk about something called constructors. Constructors. When we created this class called bird, it can have int age, it can have a double weight, it can have a string name. All right. Or actually, let's take this account example itself. My bad. Let's take this account example itself. Okay. Now, when I want to create an account, is it always the case that that account will the starting amount for that account will be 0? Is that the case? Not necessarily, right? Not necessarily. Also, if I'm creating this account, right? When I did something like this, so when I did the following, that bank account equals to new bank account, right? Then what do you think is the value of amount, holder name, and account number? So if I print account dot holder name at this point, what will I get? I will get nothing, right? I will get a null value over here. Yes, no, it won't be a garbage value. It will be a null value. Fair enough. Similarly, if I print account dot amount, then what will this be? This will be 0. Fair enough. Because integers are initialized, doubles are initialized with zeros. Okay, 0.0 actually. Right, so something like this. Now, it might be the case that I want to create an object like this. But what if, while creating the object, I also want to initialize the object? Yes. What happens when apart from creating the object, I also want to initialize the object? Then what will I do? I will use something called an initializer. Right? I will use something called an initializer. Okay, so I can come over here and I can say public bank account, right? And over in the initializer, I can accept some parameters. Okay, so I can accept, okay, give me a double amount, give me a, let's say, string name, give me a string number, something like this. Or let's say, let me just make this a little more pretty. Or let's say holder name. Let's say string number. Fair enough. I will take these as the parameters and I will initialize my object. Initialize the current object here. Does that make sense? How will we initialize it? Let's worry about that later. We'll come to that later. But is this idea of an initializer clear? Yes, is this idea of an initializer clear? Similarly, in Python world, what you have is def class bank account. In Python world, you have the following. You have a def dunder init that takes the self, that takes the amount, that takes the name, that takes the number, something like this. Fair enough. This is called the initializer. Is that clear? Now, ideally, this should be called the initializer, but in Java, you might have heard this being called the constructor. Yes or no? In Java, you might have heard this being called the constructor. Now, it is still called the constructor. But it does not really construct the object. It does not really construct the object. In Java, the true constructor, the thing that actually constructs the object, is this new keyword. Does that make sense? This new keyword is the actual constructor. Right? This new keyword is the actual constructor. Does that make sense? This thing that we have written over here, this method that we have written, this is just an initializer. It is still called the constructor though. Does that make sense? Cool. Now there's an interesting thing over here. You will notice that if I want to initialize this amount, then won't I have to write the following? I will have to write the following: amount equals to amount. Yes or no? If I write amount equals to amount, will that correctly initialize this? It won't, right? So do you guys understand variable scoping? Do you guys understand the scope of variables? Yes, when I say amount, it will find the nearest amount. It will say that, okay, you have already declared an amount over here. So what you are saying is you are setting this value to itself. Okay, you are setting this value to itself. So this amount is locally scoped. This is local to the function. Because this amount is hiding, right? This is hiding this outer amount. If I want to refer to the outer amount, I will have to specifically say this dot amount equals to amount. Does that make sense? And now I can say holder name. And similarly, I can say something like account number. Does that make sense? Yes. Cool. So this is called the constructor, but this is not actually the constructor in Java world. This is the initializer. The constructor is this particular keyword over here. Fair enough? Cool. Yes, Charles, Java does not have an initializer list. Okay. Cool. So is the idea of a constructor clear? Is the idea of the variable scope clear? Yes, is the idea of a variable scope clear? Perfect. Now, while we are on the topic of a variable scope, let's discuss one more thing. So let's discuss variable scope. If we have a class, let's say a bird, okay, or if we have an int age, if we have a void fly, in this we are taking, let's say, string height, int height, and we have an int distance from ground, okay, something like this. Yes. So over here in this particular piece of code, you will see that we have a bunch of variables. Right? We have a variable called distance from ground. Yes. We have a variable called height, and we have a variable called age. You guys can all see that. Yes. Let's quickly talk about the scope of these variables. Right? What we mean by scope? We mean kind of the lifetime of these variables. So for how long are these variables alive? Number one, and where are these variables accessible? Right? So by scope we mean lifetime and where are these accessible. Is that clear? So this int distance from ground, what is the scope of this variable? What is the scope of this variable? This variable lives inside this function flag, right? Inside this method flag, because it has been declared inside this method. Right? So this exists only inside the fly method. Fair enough? So if I come outside, if I create another method over here, void eat, and if I try to use the distance from ground, if I try to use this over here, then this is an error. Because distance from ground has not been declared inside this function. It is declared only inside here. Does that make sense? On the other hand, if I talk about age, age is shared amongst all these methods because age belongs to the class itself. Right? So age will be amongst the object. Does that make sense? So I can use age over here. This is fine. Does that make sense? Because age has been declared at the class level, it will be shared amongst all the methods of the object. Does that make sense? Yes, cool. Now, apart from that, what if I want to share? What if I want to share and some variable across the objects of a same class? What if I want to share some data across the object of the same class? Okay. So perhaps I want to have something like I want to say that I want to say that all birds, right, they will fly only at a specific time of day, or let us sleep, will sleep at a specific time. Okay, so I want to define this time. I want to say that, okay, I have some time over here, let's say string time for sleep. Okay, and I want to make sure that no matter how many birds I create, bird b1 equals to new bird, right, bird b2 equals to new bird, bird b3 equals to new bird, no matter how many birds I create, b1 dot age, b1 dot time for sleep is the exact same thing as b2 for time for sleep. Okay, what do I mean by the exact same thing? This means that if I change this, if I say that, okay, b1 dot time for sleep equals to 20, then b2 for time for sleep, if I print this, then this will also print 20. Does that make sense? The moment I change this for this object, it will be changed for the other objects as well. This is what I mean by being shared amongst all objects of the class. Yes, if I want to specify that, then this kind of a variable is called a class variable. Okay, this variable that we have over here, this age variable, this is an object variable, or basically an instance variable. Yes, why? Because it exists within the instance. Right? Why? Because it exists within the instance. This variable over here, this is a local variable. Right? Height, comma, distance from ground. These are local variables. Yes. So is this idea clear? What is a local variable? What is an instance variable? What is a class variable? Yes. Currently, this is not a class variable. Currently, I want to make it a class variable. Right? Currently, I want to make it a class variable. The way you do that in Java, is by using the static keyword. Now, once again, in different programming languages, you will use different ways of creating a class variable. Okay, in different programming languages, you will have different ways of creating a class variable, but the concept must be clear. An instance variable exists only for that instance, only for that object. A local variable exists only for that method or that scope. A class variable exists across all the instances of that particular class. Does that make sense? Yes. For example, Ajay is asking, what about in Python, right? How would we create a class variable in Python? In Python, you don't have a static keyword. Right? So in Python, so let's talk about Python. So in Python, if you have a class board, okay, if I write some, if I want to create, let's say def under init self, okay, if I say self.age equals to 20, right? Def foo self, right, print self.age, and I can say, let's say height distance from equals to 10, right? Something like this. Or I can say b equals to bird, say b2 equals to bird, right? In Python world, this thing, whenever I use self on something, this is an instance variable. Okay? Whenever I have this variable standalone, then this is a local variable. Fair enough. If I want to create a class variable in Python, I will do that over here. And for that, I won't have the static keyword, right? I will simply say, let's say time for sleep equals to, let's say 12 p.m. Okay, now if I do b1 dot time for sleep, right, equals to, let's say 1 a.m. If I print b2 dot time for sleep, then this will also print 1 a.m. Does that make sense? In this case, this is a class variable. Okay? So the syntax will differ from programming language to programming language. Okay, the syntax will differ. In Python, you will do something else, or alternatively, you could have said something over here. You would have said bird dot time for sleep. Right? This is another way of, let's just write this over here, of accessing the class variable. Okay? So in different programming languages, you will have different ways of accessing the variable, of declaring the class variable, but the concept is the same. Right? The concept is the same. Is the concept of this class variable, instance variable, and local variables clear to everyone? Perfect. Cool. So awesome. So let's quickly recap what we have studied so far. So far we have studied things like classes. Right? We have studied things like objects, constructor. Right? We have studied things like methods, functions, and we have studied variables, right? Class variables, instance variables, and local variables. Fair enough. Cool. Now we have a lot of other stuff to cover. So we want to cover things like inheritance. We want to cover polymorphism, encapsulation, a ton of other things. Okay. But before that, let's quickly take a breather. Let's take a break. Right? Let's try to digest all these things. Fair enough. So I mean, we are going to have a break. So it's currently 9:11 in my clock. Right? 9:12 in my clock. So we'll go on a break from 9:20, let's say 9:25. Okay, we'll go on a break from 9:25 to 9:35. Fair enough. Now, in these, in these present 10 or 12 minutes that we have a special guest over here today, who is Harsh. Harsh is an alumni of SCALER. Right. So let me quickly check if Harsh is already here.
Hey, Prag, I'm here.
Kumar, Harsh is here. So Harsh, can you unmute yourself?
Yes. Can you hear me?
Everyone see Harsh?
Right.
Yes, perfect. Cool. So yes, I can also hear you, Harsh. We can continue. So let me quickly introduce Harsh. Harsh is currently a data engineer at Walmart, and he's an ex-mentee from SCALER. So he's an alumni with us over here. Rohit is saying that he looks older than the teacher. That might very well be the case. I'm not exactly sure. Right.
Yeah.
So Harsh, a very warm welcome from all of us. So the reason we have Harsh over here is to share some tips with you guys. Right. So before we move on to all of those, Harsh, could you quickly tell us something about yourself? Could you help us understand your journey a little better?
Yeah, sure. Like before joining Walmart, I was like I have switched 3 service-based companies, and I was looking to switch to a product-based company. And I have friends on working on Amazon features who got placed from SCALER from there. He told me about it, and like I already have 4 years of experience at that time, and I don't want to waste more time. So I joined it now. I joined SCALER like last January, and like after joining, after 4 months, I got the offer from Walmart, and in this period, like I have solved like DSL questions, designing questions, and like great help I'm getting from mentors as well. Like previously, I was when I joined, like a mentor is not teaching on anything else, but like he helped me building resume and building my profile. He like helped me to get a call from companies like Apple as well, and Apple, Amazon, Walmart, this Uber. I get a chance to interview in great companies and like crack interviews. Like it was great experience, learning experience.
Cool.
And like
So Harsh, could you tell us things like, before going into Walmart, before joining SCALER, what companies were you working at? Right? What college, what background, are you coming from? So something about yourself, right? So that the students, they get to know you better.
yeah. So my college was basically tier 3 college. So I was very underconfident. Like how can I compete people work like coming from NIT and IIT? And
Right.
I get to know the difference, like what the difference between us and them. Like they are good in DS and designing. That's
So
why company
what
hired
college were
you.
you from, Harsh?
I am from ABS IT, Ghaziabad.
ABS
It's
ID.
UPTU.
Cool.
Uh,
UPTU. I did also my bachelor's from a UPTU college. We will also have a bunch of students over here in the class from UPTU. So
like
yes.
there are 800 college in UPTU, so you can expect that.
Right. And
Yeah.
basically, what company were you working at
Like
after the college?
I started with BirlaSoft. I worked there 2 months. Oh, sorry, 2 years, 2.5 years. After
Mhm.
that, I moved to Tawant Technologies. I worked there 8 months, and then
Okay.
published Sapient for 1 year, and now in Walmart from 1.5 years.
Cool. Awesome. Right. So, guys, if you also want to connect to Harsh, feel free to reach out to him via LinkedIn. Feel free to,
Yeah,
bug him a little
sure.
bit.
Yeah,
Right.
sure.
So,
Love to help.
let's talk about your journey at Walmart. When you were preparing for Walmart, one question that pretty much everyone will have over here would be that what kind of challenges you faced during your preparation, right? What ultimately worked for you, and basically, what kind of interview questions did you had? What challenges did you face while preparing for Walmart?
So like when I start preparing, I start giving interviews. I at that time I have good confidence because I solved around 400 question in DS. The designing part yet to start, but when I joined, when I went for interview in Walmart, so it was like I never given the system design interview before that. Okay, I've given DS question like I prepared for DP, graphs, trees, linked list, arrays, but I was not prepared for system design. So I think I raised a request to someone in a scaler, I don't know the name, and he on the next day he prepared a mock interview like how to do in a system design. So that's one thing helps a lot. Like I have no idea if the interviewer asks design the system, I have no idea what to say.
Right,
Okay,
right.
like that's literally boost my confidence and like clear an interview. And whenever I give interviews, even if I'm stuck, I had the knowledge like what to do next, even if I'm completely stuck, what I learned, what to ask, what not to ask, how to get that tips like interviewer gave it time to time. So it was like that.
Awesome, awesome, awesome. Cool, cool, cool. So that's interesting. And I mean, one very important thing that I mean, this was kind of about you. I'm pretty sure that pretty much the people who are currently in the class, right, they would be looking for something for themselves, right? So the most common question that people will have over here is, can you give us some tips? If we are coming from a tier 3 college, if we are coming from some AKTU or UPTU background, and if we want to go to companies like Walmart or Uber or Google, right, all these tier 1 companies, all these difficult companies, then what tips could you share with our students over here today?
Yeah, regarding this, like one question I was asked like everywhere, like where do you use DS, where do you use design? So
Okay.
like when you're working on a low level scale, you don't use that much. But when you deal with the billions of records and millions of users, you need to utilize your skills with DS and Elco. You save with your skills. If you can save time and money for the company, then you are an asset for them. And that's what you will learn when you know the like DS and designing all those concepts with core. And when you start prepare, you can have good resources, you can have good teachers. But if you're not consistent, you won't be able to make it. You have to be consistent, even if for easy questions, medium questions, if you know, okay, I know it, please do it and do it with several time, not one time. If you did one question and you see that question 2 months, after 2 months again, and you see, okay, I've done this. Don't do that, practice that and be consistent and don't like give time when you start practicing.
I agree with Harsh over here. So in fact, at Scaler as well, what we have observed is that if we try to look at the past data and if we try to figure out what thing determines the success of any particular person, then it turns out that the previous college, all those previous background, they don't matter. The number one factor that correlates with your success is the consistency and the amount of hard work you have. Right? So students who have solved all the problems, students who are very regular in the lectures, I mean, they're almost guaranteed to be able to crack all the top companies. Okay, so that is something
Yeah.
that we have also observed. All right, all right. So, I mean, Harsh, thank you so much for being with us over
Yeah.
here. So,
Thank
I mean, guys, once again, Harsh is an alumni from Scaler. If you guys want to know more about Scaler Academy, if you guys want to basically do a one-on-one session with one of our career counselors, then you can fill this. You have this poll right in front of you, right? You can fill this poll, and if you fill yes, then one of our career counselors, one of our alumni will also connect with you, and they will be basically asking you questions about what your career trajectory looks like, what your goals and aspirations are, and based on that, perhaps we'll be able to come up with a good plan for you, fair enough, to come up with a nice preparation plan for you. Okay, so thank you so much, Harsh, for your
you.
insights. I hope that you will also be able to help some students that are currently in the chat if someone
Sure.
reaches to you on LinkedIn.
Sure. Yeah, like I'll get a lot of requests in LinkedIn questions. I'll happy to respond.
Perfect, perfect. Chalo,
Yeah.
bye bye then, Harsh. Have a nice day.
Bye. 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 Thank you. Thanks for having me. Bye.
So, guys, once again, we are about to go on a break. It's already 9:20 on my clock. So quickly, let's fill this poll very quickly. I have seen 160 responses so far only. Once again, it is not going to be the case that we are going to spam you or anything. If you fill maybe later, we will not call you. If you fill yes in this current poll, then one of our career counselors will get with you on a call. They will try to understand what your aspirations and goals are, where you currently stand, right? They will try to gauge what your knowledge is, what your weak areas are, and based on that, they will try to figure out, okay, what your best plan of action should be. So you might have questions like, okay, I am coming from such and such background. What company should I be targeting? Or I am coming from a QA role. Should I be targeting a dev role, right? What if I want to target a machine learning role, right? So you might have a lot of different career questions. If you want one of us to basically contact you over phone, answer your questions, give you a better idea of what the software engineering ladder looks like, then please fill yes over here and we'll get in touch with you. Okay, perfect. Cool. Chandra is saying, sir, what about the quiz? What about the questions? So we are going to have the questions as we move on. Okay, and towards the end we will have a bunch of other questions as well. Right. So once again, a brief recap of what we have covered so far. We talked about classes. Classes are concepts or blueprints, right, or ideas. We talked about objects. Objects are instances of class. We talked about what a constructor is. Right? A constructor is something that creates an object. Right? In Java, the real constructor is the new keyword. Whereas the initializer is also sometimes called the constructor. Right? That is just some notational mishappenings that happen. Right? A method is a function which is tied to an object. Right? We talked about variables, what are local variables, what are instance variables, and what are class variables. Yes, so far so cool. Yes, is that clear so far? Perfect. Namit is asking, instance variable is object only, right? Yes, Namit. The instance variable, it lives within that object, right? So every object will have a bunch of instance variables. An instance, just like a method is tied to an object, an instance variable is also tied to an object. Let's move on from here and let's extend to one very important concept, one very important keyword that is used whenever you talk about object-oriented programming. And that keyword, you might have heard of it, is called encapsulation. Okay. Let's talk about what encapsulation is. So first of all, everyone, coming from, let's say, class 6th, 7th, or 8th, 9th, right, we always have these taglines. Right? Taglines like mitochondria is the powerhouse of the cell. Right? Taglines like water is a polar covalent solvent. Yes, everyone remembers those taglines. So just like that, for encapsulation, we have a tagline. Right? For encapsulation, we have a tagline. Encapsulation is what? Encapsulation is data hiding. Okay? Encapsulation is data hiding. This is something that is you have to remember, because in interviews, people can totally ask you, right? And it is important to understand what we mean by data hiding. Okay. So let's first look at this word, encapsulation. Encapsulation. Okay, this basically means to put inside a capsule. Yes, when you have a bunch of different things that somehow are related, yes, that need to be tied together, what you can do is you can bunch all of them together. You can put them inside a box. Yes, you can put them inside a capsule. That is what you mean by encapsulation. Fair enough. Now, when you put some things inside a box, if the box is, we are assuming that the box is not transparent over here. Are you able to see what's inside it? You can't, right? Are you able to directly reach into the inner contents and modify them? Yes. Are you able to reach the inner contents and modify them? You can't, right? So basically, by encapsulating, you're putting a boundary, right? People can now interact with this capsule, right? But not directly with the internal contents. Does that make sense? If you put a capsule inside something, then if you put a capsule around something, you can't directly interact with the internal things. You can interact with the capsule. You can push the capsule and do other stuff with it. Right? That is what we mean by encapsulation. Now, encapsulation is very important in programming. Right? From a security perspective, from a complexity perspective, encapsulation is very important. Let's come back to this example of bank account. And we have an int amount over here, right? Let's say double amount, right? We have a string holder's name, right? And we have a bunch of other stuff over here. We have, once again, a method called void deposit, right? And we can take, let's say, double value, right? And we can say this dot amount plus equals to value. And similarly, we can have a bunch of other stuff over here, right? We can have a void find get balance. And this can do print this dot balance, this dot amount. Okay, something like this. Fair enough. So far, so good. Cool. Now imagine that we have a person. Okay, imagine we have a person who is also a programmer, and we have given their bank account to that person. Right? So we have a bank account, let's say Charles account or Charles's account, right? And we are saying new bank account, right? And I mean, we have said that, okay, Charles bank account, this folder's name equals to Charles Xavier, something like this, right? And we have given this particular variable to this person Charles. Okay, we have given this particular variable to this person Charles, so that Charles can get the balance, Charles can do the deposit and other stuff, right? But Charles is very cunning over here, right? What Charles says that, okay, I know how this thing works. I know that inside it there is something called an amount. So can Charles do the following? Can Charles say that, okay, Charles account dot amount goes to 1 million, something like this, or 1 billion, yes, or maybe 350 million, so that Charles is now richer than Elon Musk. Yes, can Charles do that? Yes, he can do that, right? Now, for Charles, this makes sense. Yes, for Charles, this is a good thing, but for the bank, this is not good. Yes, for the bank, this is not good. Right? So the bank wants to ensure that whenever I give this account to Charles, Charles can only interact with this account using these methods, using the deposit method and using the get balance method. Charles should not be able to mess with the internal details. Yes or no? That is something that I want to enforce. Right? So this is where encapsulation comes into picture. There is something called access modifiers. Right? Now, once again, access modifiers will differ from programming language to programming language. Right? There's something called access modifier. What I can do is I can basically change this code, and I can make these variables private. Okay, if they were not private, by default they were public. Now this is once again not exactly correct. In Java, public is different from default. Okay, public has different meaning, default has different meaning. There's other kind of access specifiers as well. So you might have heard of protected, you might have heard of package protected. We're not going to go into the details of all of those. Okay, the different specifiers, they just limit who can use what thing. Fair enough. But the concept over here is that you can limit who can modify this thing. Does that make sense? If you want to make sure that Charles is not able to mess with this stuff, only these functions are able to mess with this stuff, then you can hide this particular variable from the outside world by making it private. Does that make sense? Yes. Now if Charles wants to do this, right? Now if Charles says that, okay, I will take account and I will say amount equals to 350 E9, right? 350 E9. So this time the compiler will give an error. This code won't even compile. Okay, forget about runtime. This code won't even compile. The compiler will say that the private member of amount is not accessible, right, to someone outside the world. Does that make sense? Yes, this is what we mean by data encapsulation, data hiding. Is this clear? Yes. Harpreet is saying, how do you do this in Python? So Harpreet, unfortunately, in Python, you don't have anything like data encapsulation. Right? Once again, as I said, it differs from language to language. In Python, there is nothing called data encapsulation. There's an encapsulation by, since Python is a dynamically typed language, right? And since Python does not have a compile time, in Python, the encapsulation is not enforced. Right? So in Python, if you say that I have a amount, right? If you say that I have, let's say, def under init, or self dot underscore amount equals to 0, right? Something like this. Then by convention, programmers know that if the variable is starting with an underscore, then we should not modify it. But this is by convention only. By convention only, right? Nobody is enforcing that. The compiler will not enforce that. There's nothing like a compiler in Python, right? So basically, in Python, even though you have this, you can do b equals to bank account, right? You can say b dot under amount underscore amount equals to something like 350 E9, right? This is valid code, will run, but people will be angry at you. Does that make sense? Yes. In Java, on the other hand, this will not even be allowed. In Java, the compiler will complain over here. The compiler will say, no, I won't compile this code. You're doing something wrong over here. Does that make sense? Yes. Cool. Perfect. Monica is saying using reflection, we can break this in Java. So yes, Monica, no matter what programming language you have, at the end, whatever you are doing in the programming, right, everything is just bits and bytes. It's just electrons and lack of electrons in the memory somewhere. So if you can directly access the memory, if you can do something like reflection, then you can always go around and mess with some of this stuff, right? Which is why this is not the only point of security, right? Which is why banks will also keep this code at their own servers. They won't allow you to enter their servers, right? There's a lot of security policies around this. If you get access to the bank computers, you can, even though they have written the code in Java, you can still mess with it. Okay, you can simply go to the hard disk in which they are storing the values. You can change the value in the hard disk. Does that make sense? Sahil is saying, how do we prevent something like this in Python? How do we enforce something like this? So Sahil, that is kind of an advanced question. In Python, you have several things. So you can override the under get attribute, right? You can override you can override a bunch of methods. Apart from that, you can use something called name mangling. Right? So Python has something called name mangling. So you can use things like that. So we are not going to go into the details of that. If you want some good material on that, I can refer some awesome courses on Python for you. But strictly speaking, it is not really possible to enforce something like this. Okay, because you can always go around and modify something in the memory. Okay. Is this idea of encapsulation clear? Encapsulation means data hiding. Yes, because you don't want other people to mess with your stuff. Yes. Now, one very important question is data hiding versus hiding details. Are these the same thing? When I hide the data about the amount, am I not hiding the details? Well, I am hiding the details. I am hiding the details, but the purpose is different. Right? The purpose of hiding details. What is the purpose of hiding details? The purpose of hiding details is to reduce complexity. Yes. The purpose of hiding details is to reduce complexity, whereas the purpose of data hiding is to prevent malicious access. Yes or no? Is this distinction clear? Yes. Now, what do we really mean by hiding details? Let's take an example. Let's suppose that we are talking about something like electricity. Okay. So I can talk about the fact that we have something called electrons, right? And these electrons are in some sort of a quantum field, right? And we have something called nucleuses, right? And these electrons, they are orbiting the nucleus, but you have various things. So if there's an electromotive force, electric potential, right? Then these electrons will exceed the orbital binding energy, right? They might move outside the atom, right? And what will happen is that they will flow in the material, right? And you can talk about a bunch of stuff when you're talking about electricity, and you can talk about a bunch of stuff, or you can say V equals to IR. Yes or no? You can, if you want to describe electricity to someone, you can either do all this, or you can say V equals to IR. Yes. Now V equals to IR is not vague. Please note that this is not vague. This this describes the world perfectly. Does that make sense? This is not vague. It describes the world perfectly. V equals to IR, that is true. But we have described the world without giving a lot of detail. Does that make sense? We are hiding all these details. What is happening inside the actual things? We have hidden all these details. That is what we mean by abstraction. Does that make sense? That is what hiding details means. Reducing the complexity. Is this clear? Similarly, when we talk about, let's say, a car, I can talk about that car has some sort of it has some sort of a material that is strong, right? And it has some sort of a winding of electric coil, right? And it has some magnets, and it has some fuel, and it has a weird contraption, right? In which explosions occur, right? Or I can describe all this, or I can say car has engine, body. right? And fuel. Yes. I mean, in fuel also I can describe, okay, there's some hydrocarbon, right, which was formed in some manner. I can talk about all these things. So which is a better representation? I can definitely talk about all these. These are also a valid car, right? This is also a valid car, but it is much more understandable for me to describe car in this manner. This is what we mean by data hiding, and data hiding is abstraction. Right? Data hiding, abstraction is data hiding. And notice that abstraction is not the same thing as being vague. Okay, so there's a very, very famous quote over here. Let me just find what that quote is. Abstraction is not the same. Yes. So this is a quote. This is a wonderful quote by Dijkstra. So how many of you have heard the name Dijkstra? Yes, how many of you have heard the name Dijkstra? Let's see. I'm going to copy this piece. Just give me a second. Yes. So Dijkstra is, I mean, he was a mathematician, he was a computer science person, not the Dexter TV series guy. So he's a very, very famous person in computer science world at least. And he had given this quote that being abstract is something profoundly different from being vague. The purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. Okay, this is a very, very important quote. And we have to understand this. Abstraction simply means hiding the details. It does not mean that doing something wrong or doing something in an incomplete manner. Fair enough? Abstraction is, sorry, hiding details. My bad. So sorry. Hiding details. Encapsulation is data hiding. Does that make sense? Yes. Is this clear? The distinction between abstraction and encapsulation, right? Cool, perfect. Now let's move on to some more things. Let's do a little more deep dive on something called relationships. So I said that different objects, they have relationships with other different concepts have relationships with other concepts. And so far, we talked about a has a relationship. Yes, we said that a bird has a wing, right? Bird has a beak, and so on and so forth. Yes, we can be a little more precise over here. We can describe this in more details. Okay, we can describe this in more details. When we talk about has a relationship, the bird has a beak. That is true. Can the beak exist without the bird? I mean, physically, yes, it can exist without the bird. You can have a dead bird with a dead beak, right? And the beak can be separated. But logically, it does not make sense. Right? Whenever you are talking about a beak, you will always be talking about a bird as well. Yes. Similarly, or can we say that, does the bird own the beak? If the bird dies, then does the beak also die? It does, right? So yes, we were talking about birds and beaks, right? So can the beak exist without a bird? Does the bird own the beak? It does. Yes or no? This kind of a thing, this kind of ownership is a has a relationship, but this is called composition. Does that make sense? Or alternatively, we are saying that a bird is composed of beak, wings, legs, I mean, perhaps a stomach and other things. Cool. So is this composition clear? In composition, something is owned by something. Right? So if I say that car has wheels, then this is composition. Right? Can I take some other example perhaps? Let's say that we have students and courses. Okay, let's say that we have students and courses. If a student, let's say, removes himself, let's say basically leaves the course, should I cancel the course? If a student leaves the course, should I cancel the course? That does not make sense, right? Other students might have that course. Yes. Similarly, if a course gets cancelled, should I murder the student? Definitely not. Right? So in this case, we have a relationship. We have a relationship that student has course. And we also have a relationship that course has student. But in this relationship, there is no ownership. Yes or no? In this relationship, there is no ownership. This kind of a relationship, this kind of a has a relationship without a ownership, this is called an aggregation. We're aggregating things. You are saying that, okay, a student can have a bunch of courses. You're aggregating things. Does that make sense? Right? And together, when you talk about hazard relationships, hazard simply means association. You're associating two things together. You are associating two things together. You are saying that, okay, something has something. That is what you mean by association. When you say that there is ownership, right? Then you say that this is composition. When you have no ownership, then you say that this is aggregation. And this is a very, 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 very common interview question. Okay, so I mean, if you have gone to an object-oriented programming interview, then yes, you're very likely that someone will ask you this. What is association? What is composition? All these things. Okay, explain association once again. So association simply means a hazard relationship. I mean, both composition and aggregation, they are associations. Right? Association is the umbrella term for a hazard relationship. Does that make sense? Yes. So every hazard relationship is an association, but I can be a little more specific. I can talk about in this association, if there is ownership, then I will call it a composition. If in the association I don't have ownership, I will call it an aggregation. Okay. So let's take some more examples. So currently we have masterclass, right? And masterclass has attending people, right? It has an instructor, right? It has, let's say, a feedback form, right? Perhaps it has a video link, or let's say lecture link, okay? Things like this. Yes, so masterclass has all these things. Yes or no? So all of these are associations. But does the masterclass own the attending people? Does the masterclass own the attending people? No. So this is aggregation, right? No ownership. Okay. Does the instructor own the masterclass? Kind of, sort of, yes. Right? The masterclass does not own the instructor, but the instructor kind of owns the masterclass. If the instructor falls sick or the instructor is not available, then we might have to cancel the masterclass. Yes. So we can say over here, instructor owns the masterclass. Yes. This is composition. All right. What about the feedback form? Does the feedback form own the masterclass? No, clearly not. The masterclass, on the other hand, owns the feedback form. If this masterclass gets cancelled, then the feedback form should also be deleted for this masterclass. Yes or no? Right? If the class gets cancelled, then the feedback form for this class loses its meaning. Yes, there's no purpose of the feedback form for this class if the class has not happened itself. Right? So then the feedback form should be removed. Yes, so this is composition. Similarly, the lecture link. If the class gets cancelled, then the class owns this particular lecture link. If the class gets cancelled, this lecture link has no meaning. Yes or no? Is this idea behind aggregation, composition, and association clear? Yes, this is dependence versus independence. Cool. Mayank is saying, so every association should either be a composition or an aggregation. Exactly. Right? Exactly. So every association should either be a composition or an aggregation. Param is saying code example please. So yes, let's take an example of this thing itself. So we have a class called masterclass. Okay. In a masterclass, we have a class called instructor. Okay. We have a class called, let's say, class link. All right. And we have a class called, let's say, person or user. Okay, so what we have is, we have instructor. Instructor can have, let's say, a name. So we can have an instructor plug here equals to new instructor. Okay, something like this. We can have a master class. So we can have, let's say, it can have a string name. We can have an instructor. Similarly, this instructor can have, you can have a bunch of master classes. So list of master classes conducted. Right? A user can have, let's say, a string name. They can have a list of master classes attended, something like this. Okay, and we can have a class link as well. So perhaps this will have a URL, something like this. Right? Cool. So in this case, let's forget about this. In this case, notice that in the instructor, I have classes conducted. In the master class also, I have instructor, right? So, I mean, both of these are associations. An instructor is associated with a master class. A master class is associated with an instructor. But who owns what in this case? who owns what in this case? In this case, the master class does not own an instructor. This is kind of a back reference. Yes, this is kind of a back reference. If the master class gets deleted, then I should not remove the instructor as well. Right? Just because the master class gets cancelled, that does not mean that Pragya is going to be fired. Yes or no? Whereas if the instructor gets cancelled, if Pragya gets fired, right, or if Pragya falls sick, then perhaps we might have to cancel the master class, or we might have to transfer this master class to someone else. Yes, to some other instructor. Do you guys agree? A master class cannot exist without an instructor. Yes. So over here, this is composition. This is aggregation. Does that make sense? Piyush is saying is inheritance and aggregation. So Piyush, currently we are talking about has-a relationships. Right? In all these, we are talking about has-a relationships. Basically association. We'll talk about inheritance in a little while. Fair enough? Okay. Fayaz is saying, what if the instructor's only job is a master class? Well, still Fayaz, let's suppose that we have a specific instructor called a master class instructor, and their only job is to construct master classes, right? Still, if the master class gets cancelled, I should not fire the instructor, right? Because this master class got cancelled. That instructor might be taking 10 different master classes. Yes or no, Fayaz? That instructor might be taking more master classes. What is back reference aggregation? No, back reference, basically this is an example of aggregation. So this is a has-a relationship. This is aggregation. And simply saying that why do we have this variable over here? This variable is supporting some sort of a back reference use case. Right? If the master class wants in from the master class, I want to quickly access who the instructor for this master class is, so I can maintain a back reference to the instructor in this master class. This master class, however, does not own the instructor. Does that make sense? Yes. Perfect. Cool. Similarly, in this user, we have classes attended. But if some user decides that, okay, I don't want to attend the class, in that case, should I cancel the master class? I should not, right? I should not. This is aggregation once again. Notice this. Over here, instructor has list of master classes, but this is composition. User has list of master classes, but this is aggregation, right? So the data type or the cardinality, right? How many things are associated with how many things, that has nothing to do with composition or aggregation. It's basically what we mean by it. Yes, it's basically how the world works. Does that make sense? Yes. Fair enough. Ankur, yes, these languages, these concepts are language agnostic. Right? They're not tied to Java. These concepts of aggregation or generalization, they are not tied to Java. You can have this in any language. Cool. Rituraj is saying, what is the practical use of knowing these relationships, of knowing all these things? So Rituraj, that's a great question. These all things are very important when we are actually building products. Okay. Let's suppose that you become the CTO. Right? You become the CTO of a fancy company. Right? Let's suppose that Tesla reaches out to you. Right? Tesla reaches out to you, and Tesla tells you that, okay, Rituraj, we are very impressed by your portfolio. We are very impressed by the things that you have done. We want you to lead Tesla, to lead the technology department in Tesla. Right? Now at Tesla, you have all sorts of weird problems, right? All sorts of weird tech problems. How do you start thinking about those things? Yes, there's a lot of complexity over there. Right? You have tons of things that you can do. How do you even start? Where do you even start? Right? That is what we learn in something called low-level design. Right? Low-level design. That is something what we learn in this particular thing. Right? And all these concepts that we are studying, right? What is encapsulation, what is generalization, what is association composition, all these concepts will be very useful when we expand more on the low-level design part. Fair enough. So in the masterclass, of course, we won't be able to cover this, but in Scaler Academy, we have 1.5 months of classes and a ton of assignments that are dedicated to low-level design. So if you want to learn more about this, feel free to join us. Okay. So is this idea of encapsulation clear? Is this idea of association and aggregation and composition clear? Yes. Perfect. Now, so far we have talked about has-a relationships, but there is another very important kind of relationship, which is a relationship. Yes, is a relationship. A car is a vehicle. Yes, a car is a transport. A car is a let's say automobile. a car, on I can say a Honda Civic is a car. Does that make sense? All these things. Apart from that, I can perhaps I can say that. I mean, so basically, what I want to express over here is that is a relationships exist. So I can let's look at another hierarchy. So I can say that okay, a sparrow is a bird. Yes, I can say that a bird is an organism. Right? I can say that let's say a bird is let's say animal, right? And I can have a bunch of things over here, right? I can say that okay, let's say blue-beaked sparrow is a sparrow. Right? It's a special type of sparrow. I'm not sure if blue-beaked sparrows exist, and I just made this name up, but I can say something like this. Right? So all these are describing is a relationships. Okay. Now remember, in case of has a relationship, how did we model that in code? How did we model class sparrow? How did we model the has a relationship in code? We said that the sparrow has wings. So we can say wing, left wing. Yes, this is a has a relationship. What about a is a relationship? How do we model a is a relationship in code? Okay, that's the question. Now to understand that, we have to first understand what do we really mean by is a relationship. Right? When we say is a relationship, what are we implying by it? Right? What are we implying by it? When we say that a car is a vehicle, or when we say that let's look at this thing. A sparrow is a bird. Okay? What do I really mean by this statement? The meaning of this statement is that anything a bird can do, right? A sparrow can also do. Yes or no? Anything that a bird can do, a sparrow can also do. Anything that a bird has is any attribute that a bird has. Every sparrow will also have those attributes. If a bird has weight, a sparrow has a weight. If a bird has height, a sparrow has a height. If a bird can fly, a sparrow can fly, and so on and so forth. Yes or no? Does that mean that? Can I also say that everything a sparrow can do, a bird can also do? Can I say that? No, I cannot. Right? I cannot say that. For example, a sparrow can fly. Can all the birds fly? Can all the birds fly? No. Right? Kiwi can't fly. Yes. Similarly, penguin can't fly. Does that make sense? Ostrich can't fly. Yes. So when I say is a relationship, it is very important. I'm saying that a sparrow is a bird. And there's a hierarchy. There's a direction to this relationship. Yes. There's a direction to this relationship. A sparrow is a bird. A bird is not a sparrow. Yes or no? Right? A sparrow is a bird. A bird is not a sparrow. So how do we define is a relationship in code? To define is a relationship, if we want to encapsulate this thing, right? We want to make sure that these properties are satisfied in the code as well. Right? So basically, we have a class called bird. Right? The bird has int age. It has a string name, right? Or perhaps it has a wing left wing. Okay, and we have let's say void eat. Okay, print pet. Something like this. Okay, we have a class bird. Now I want to make sure that sparrow has everything that a class bird has. So what I can do is I can literally copy paste this. Yes, I can literally copy paste this. But if I copy paste it, if something changes over here, I will have to modify this as well over here. That will also lead to a bunch of duplicate code. So I don't want to do that. I want to simply capture this idea. That everything that a bird has, a sparrow also has. So for that, let's create a new concept. Let's create a new keyword. The keyword extends. Right? So in Java, this is how we do it. In the Python world, you would do this differently. In Python, you would do the following. So class bird, okay, and you will have class sparrow, and you will simply put birds in the bracket over here. Okay, so once again, different languages, different syntax, but the idea is the same. When we say a sparrow extends a bird, everything that a bird has is literally getting copy pasted into the sparrow. Does that make sense? Everything that a bird has, it is getting copy pasted into the sparrow. So if I come over here, if I say sparrow s equals to new sparrow, okay. If I say s dot eat, if I say s dot eat, in this class I don't have any eat method. Yes or no? In this class I don't have any eat method, but I do. It is just hidden. It is coming. It is being inherited. Right? The eat method is being inherited from the bird class. Does that make sense? Yes. Harpreet is saying, can you explain hazard relationship in Python? Definitely, Harpreet. I mean, hazard relationship is just composition, right? Just association. So I can say self dot left wing equals to wing. Okay, so basically, I'm saying that I have a left wing. Does that make sense? Yes. Charles is saying, can we say bird is injected into the sparrow and this is just syntactic sugar for it? Well, that depends from language to language. Okay, that depends from language to language. In a language like Java, it is not literally being copy pasted over here. Okay, it is not literally being copy pasted over here. There's some other things. Okay, there are some other things. So basically, this is what we mean by inheritance. Right? This is what we mean by inheritance. This sparrow will inherit everything that a bird will have. Okay, and you can use those things. You can use the attributes. You can use the methods defined on the board with a sparrow as well. Does that make sense? Yes, no? Yes, cool. Perfect. Namit is saying, how would you code student has a course? So this is how we did that, right? A student has a list of master classes. Okay, that's literally it. Cool, so far so good. Is this idea of inheritance clear? Yes. Perfect. Now let's take some interesting examples. Let's say that we have a class called board. Let's make this Java. And we have a class called Sparrow. And in this, perhaps we have an int age, we have a string name, right? We have, or let's say string species. And we have a void eat. Right? And we can print, let's say, peck at the ground. And let's say we have a, let's say, eagle. All right, now eagle can have a bunch of other stuff. So eagle can have a void hunt. Yes, eagle can have a void hunt. It can say that, okay, I mean, do some hunting, something or the other. Yes, this void hunt, it exists only on eagles. It does not exist on bird. Yes or no? So I can do something like this. I can say bird b equals to new bird. Bird. I can say eagle e equals to new eagle. I can call eagle dot fly. Sorry, eat. This works. Similarly, eagle dot hunt also works. B dot eat works, but B dot hunt. Will this work or not? B dot hunt will not work. Does that make sense? Oh, sorry, I have not inherited, my bad. I forgot to do that. Thank you for pointing that out. This extends board. I have to make sure that eagle inherits the board. Okay. Yes, Fayaz. Is a relationship means inheritance. Okay, is a relationship means inheritance. Does this make sense? Cool. Now let's ask ourselves some things. What if the eagle wants to eat a little differently? So basically what we want to say is, whenever the eagle wants to eat, perhaps it will have to hunt first, or it will have to do something else first. So eagle wants to have its own implementation of void eat. It will have to have its own custom implementation of void eat. So instead of pecking at the ground, it will first hunt. Okay? Then let's say gracefully clear flesh, something like this. All right. So can this eagle have its own implementation of void eat? Yes or no? Well, in this case, I told you that you can think of inheritance as literally copy pasting this code. Right? You can think of inheritance as literally copy pasting this code. So if you copy paste this code, if I literally copy paste this code, is this code now correct? Is this code now correct? No, it is not. Why? Because I have two functions. I have two methods with the same signature. Yes. Do you guys understand method overloading? Do you guys understand the concept of method overloading? Right. So basically, if I have, let's say, int add int a comma int b, right, or return a plus b. Right? I can have another int add int a comma int b comma int c, and I can return a plus b plus c. Okay, this is overloading. I am saying that add is an overloaded thing. It does more than one thing. Right? It can perform more than one thing. I have more than one function with the same name but different signatures. Yes, this is not what I'm talking about. Over here, right? Over here, we have void eat and they have the same signature. Yes, so these are not overloaded. These are not overloaded, and you can't have two methods with the same name. You can't have two methods with the same name and the same signature. So what can you do over here? You want to tell the compiler that in the eagle, I am kind of overriding the previous method. I want to say that, okay, I have inherited this from the bird class. That's true. But I don't want to use this. I want to implement my own implementation. I want to have my own implementation. I want to override. Yes, I want to override the eat. Does that make sense? So for that, I can specify the keyword add override over here. Yes. Now in Java, this is not mandatory. Right? Writing this override keyword is not mandatory. Even if you omit this, the compiler will automatically understand that you have overridden this method. Okay, but it is a good practice to specify this keyword. Is that clear? So what does overriding allow us to do? What does method overriding allow us to do? It allows us to provide custom implementations of methods inherited from the parent class. Does that make sense? Yes. Cool. Yes, Harshit, this is known as an annotation in Java. When you write add something, this is known as an annotation. In Python, when you do this is known as a decorator. Things are different, but I mean, don't really worry about how annotations or decorators work at the moment. Fair enough. Is this clear? What method overriding is and what is method overloading? Method overloading. This is two functions, multiple functions with the same name but different signatures. What do we mean by signature? Parameters plus return type. Okay, that is what we mean by the signature. Yes. Sanjay is saying, is overriding an anti-pattern? No, Sanjay. Overriding is not an anti-pattern. Overriding is an essential thing in object-oriented programming. I mean, if you don't have overriding, then object-oriented programming is kind of a, stupid thing. Because you could always copy-paste this code, right? You could always copy-paste this code. So in that case, this extends keyword is always just a syntactic sugar, right? So to make this more powerful, to give the idea that, hey, an eagle is a bird. It gets everything, but it can do some certain things differently. This is what we mean by talking about overriding a method. Does that make sense? Yes. If one is of type void and the other is of int return type, then is it function overloading? Yes, exactly, Vivek. If one is of type void and the other is of int, then that is function overloading. Fair enough? Yes, is that clear? Perfect. So this is known as inheritance. I mean, so far we have covered inheritance. Right? And inheritance, there's another word that is used for inheritance that is called generalization. Okay, this is called generalization. Now, let's quickly talk about this word called generalization. So far, we have been looking inheritance from the top-down manner. Right? We have been looking this in the top-down manner. Right? We said that there's a bird. Right? We said that there's a bird, and we said that we have a sparrow, and a sparrow is a bird. Yes, that is what we did. Does that make sense? Now let's look at this in a bottom-up manner. Bottom-up fashion. Let's look at this in a bottom-up fashion. Let's start with something like a bird. Okay, and in this bird we can have a void eat, we can have an age, we can have a bunch of things. Okay, we can have a bunch of things. But after some time, I want to have a class for a dog as well. Yes, I can have a concept for a bird. I can have a concept for a dog. Yes or no? In a dog, I will also have a void eat. In a dog, I will have a void bark. I will also have an age. Yes or no? But again, I can have another thing. So perhaps I can have a cat. And for this, once again, I will have a void eat. I will have a void meow. And I will have an age. And after creating all these classes, I will notice that there is something common within these classes. Yes, I will say that there is something common within these classes. So generalization. Generalization is the act of taking the common things and pulling them up. Okay? So basically, I can say that instead of declaring these separately, let me create a new concept called an animal. Right? Let me create a new concept called an animal, and then let me put the void eat inside it and the age inside it. And now I can say that I have a bird, and bird is an animal. And I can say that I have a dog, it is an animal, and a dog will also have bark. Right? And I also have a cat is animal, right? And I will have a void meow. Does that make sense? Yes. In the top-down approach, we started with a bird. We said that okay, a sparrow inherits everything that a bird has. Right? So a sparrow is a bird. In the bottom-up approach, we created many unrelated concepts. But then we realized that hey, these concepts, they're kind of the same, right? They're similar in some aspect. So let us take the similar part out and pull it up. That thing, that action that we did, this is known as generalization. Does that make sense? How do you achieve generalization? The only way to achieve generalization is by using inheritance. Yes, I mean, that's not exactly true. There are other ways of achieving generalization as well. But one of the ways of achieving generalization is by using inheritance. Does that make sense? Yes. Yes or no? Now, once again, it is very important to understand. Very important to understand the difference between abstraction versus generalization. Okay, this is very important to understand. When I say abstraction, I'm hiding details. Right? For example, when I said that we have a car, right? A car has wheels, it has windows, it has engine, it has body, right? It has a bunch of other things. It can move, it can honk, right? It can do a bunch of things. Right? This is what abstraction means. On the other hand, generalization. This means that basically abstracting out the common things in a new hierarchy, in a new concept. Okay, so basically from car, if we say that okay, we have a car, we have a truck, we have a bike, we can generalize all these into a vehicle. Does that make sense? Yes. Cool. Now I see in the chat we have a lot of questions on solid principles, on Liskov substitution principle, right? Whether this satisfies one of those principles or not, or so on and so forth. So once again, we won't be able to dive into all those solid principles or the design patterns and all that stuff. Let us keep the conversation to object-oriented programming. If you have more questions about that, then I would strongly recommend that you attend the other master classes as well. Right, so exactly, a masterclass for solid principles is scheduled. I think Kshitiz is going to take that on, I think 17th. Right, so if you're more curious about that, please join that masterclass. Fair enough? Is this clear? Cool, perfect. Right, so is the difference between generalization and abstraction clear? Yes. Please explain generalization again. Definitely. So generalization simply means taking the common things, right? When you have multiple different concepts, you realize that, okay, there is something common between these concepts. When you take those common parts and you pull them up into the hierarchy, inheritance hierarchy, that is something that you call as generalization. We usually achieve generalization by using inheritance. Does that make sense? We achieve generalization by using inheritance. Does that make sense? Yes. Is it similar to interface? No. Chandra, interfaces serve a completely different purpose. We'll come to what interfaces are. But interfaces serve a completely different purpose. All right. Cool. Now, I'm getting a bunch of questions over here. Questions like, what is super? Right. Let me quickly write the questions over here down. What is interface? Right. Questions like we might have things like, what is instance of? Right. What are abstract classes? Right. What are classes versus types? Right. What is typecasting? What is runtime polymorphism? Right. What is method resolution order? Right. What is multiple inheritance? What is multi-level inheritance? Right. So object-oriented programming is a vast subject. Yes, there are all these things that we can talk about, and of course, much more. Right. What are pure functions? What are virtual functions? We can talk about a lot of different things. Unfortunately, we won't have the time to cover all these things in the class today. Okay, this is just a 3-hour class. We won't have the time to cover all these things in the class today. So let's quickly look at one or two of these things. Okay, let's quickly look at what is super. Okay, and let's quickly look at abstract classes. And finally, if we have the time, let's also look at interfaces. But this is where we will call an end. Fair enough. Cool. Let's also look at polymorphism. Let's also look at runtime polymorphism, because this is going to be important. So let's first talk about runtime polymorphism. I told you that a sparrow is a bird. Yes, I told you that a sparrow is a bird. So can I do the following? I have a class sparrow. Right? I have a class bird. In this, I have an int age. I have a void, let's say, eat. Okay. In this class sparrow, I have a void, let's say, fly. Okay, something like this. If I come over here and I say that bird B equals to new bird, all right, and I say sparrow S equals to new sparrow, is this code fine? Is this code fine? Yes, this is fine. Okay, this is also okay. Okay, if I come down, if I write bird B2 equals to new sparrow, what about this? Similarly, if I come down and write sparrow S2 equals to new bird, what about this? It turns out that this is okay and this is not okay. It turns out that this is okay and this is not okay. Let's try to make sense of why that is the case. Right? It is not that we have arbitrarily defined these things. There's a specific reason for it. So when I say that we have a bird B2, when I say that you have a variable B2, right? So if I define a method, let's say void do something with bird, right? And I have a bird B over here. Okay, if I'm defining this function, does it really matter what I get over here? As long as, so in this function, I have a bird B object. So I will be trying to, let's say, get the age of it. I will be trying to make it eat. Right? I will be invoking these two things. I can invoke these two things on the bird. Yes or no? Can I do something else on the bird? I can't, because a bird only has these things. Do you guys agree? Yes or no? Cool. So in this method, in this particular function, instead of passing a bird B, what happens if I pass a sparrow? What happens if I pass a sparrow? Right? What happens if I pass a sparrow in this? Well, if I pass a sparrow in this, a sparrow also has an age. Yes. A sparrow also has eat. Yes or no? A sparrow also has age. A sparrow also has it because a sparrow extends a bird. So shouldn't this method work with a sparrow as well? Logically, we're not worrying about the syntax right now. Logically, because a sparrow has anything that a bird has, if this function is doing something with a bird, it can do that same thing with a sparrow. Right? So this function must work with a sparrow as well. Yes or no? Which is why it is okay to put a child class object in a parent class variable. Right? It is okay to do parent class object equals to new child class. This is fine, because everything that you expect a parent class object to do, the child class object can also do it. Does that make sense? Yes, anything that you expect a parent class object to do, a child class object can also do it. And this facility that you can pass a child class object when a parent class object is requested. Over here, I requested a bird object. Over here, I requested a bird object, but I can totally call this function with a new sparrow object. Okay, I can call this, even though a bird was expected, I can call this with a child class object. This facility is known as runtime polymorphism. Does that make sense? Yes. Cool. Perfect. Now we have a bunch of questions over here. A bunch of questions can come into your mind. Let's take a more complicated example. And let's try to make sense of some more things. Let's say that we have a class board. In this we have an int age. We have a void fly, or let's void eat, and this is saying print packet ground. We have a class, let's say sparrow, extends bird. We have a void fly, print flap wings. We have an override, void eat, print, let's say warm, something like this. If I have a class bird b equals to new bird, if I say b.eat, then what will this call? What will this print? If I say b.eat, what will this print? This will print packet ground. Why will this print packet ground? Because I have an object. I have an object of type bird. Okay. Notice that there are two things over here. Number one, this thing over here. This thing over here. This is the type of variable. Fair enough. On the other hand, this thing over here. This is the type of the object. You guys understand this difference? I have an object of type bird. I am storing that object in a variable of type bird. Yes? Cool. Now, when I call b.eat, this eat will be invoked on the object. So does eat exist on the object? It does. So this will print packet ground. Okay? Cool. Let's suppose I say sparrow, s equals to new sparrow. Okay. And I say s.eat. What will this print? This will print pickworm. Why will this print pickworm? Because this sparrow, this variable s is holding an object of type sparrow. In this sparrow, I have a void eat. It is coming from the bird as well, but I have also overridden it. Right? So this will print pickworm. Fair enough? Okay. What if I do the following? Bird b2 equals to new sparrow. And b2.eat. What will this print? Let's see. This time around, I have a b2, right, which is of type bird. So should it print eat or should it print this pickworm? So this will print pickworm. Why will it print pickworm? Because the method is tied to the object and not the variable. Yes, methods are always tied to objects. What is the type of the object? The type of the object is sparrow. The type of the variable is bird. Yes or no? Type of the object is sparrow. Type of the variable is bird. Methods are always tied to objects. So when you call the method eat, it will go into the sparrow's eat method. Does that make sense? Yes or no? Right? Okay. Let's suppose that I do the following. I say that, okay, if I say b2.fly, what will happen here? If I say b2.fly, what will happen here? This will give me a compile time error. Why will this give me a compile time error? So this function is tied to the object. This function is tied to the object. But before you can invoke a function, on a variable, you have to first make sure that the variable has that function. Yes or no? You have to first make sure that a variable has that function. When we are talking about this variable B2, what do we know about B2? We know that B2 is of type bird. Yes. Does bird have the fly method? It does not. Does bird have the fly method? It does not. So for someone, right? So let's suppose that currently we can see, right? We as the person can see that, okay, actually we have stored this in a bird, but actually this is a sparrow, right? We can see that. But imagine if this was a function, right? And this was expecting a bird B, and this was trying to do b.fly. Right? If someone calls this function do something, the new bird, then this function should fail, right? Because it has a bird. It should not be able to call fly, because fly does not exist in a bird. Does that make sense? Now, it can call eat. This is fine. This is also fine. Because whatever this function will do, the sparrow will also be able to do that. Yes, but calling fly on a class on a variable of type bird will not work, even though the object is of type sparrow. Yes, the compiler will complain over here. The compiler will say, you have told me that B2 is of type bird. I don't see a fly method on B2 of type bird. Yes, on the runtime, maybe the B2 that you have given me is a sparrow. But at the compile time, all I know is that this is a bird. Does that make sense? Yes. Let's talk about the third thing. It says sparrow s2 equals to new bird, s2.fly, and s2.eat. What will this call? What will this fly call, and what will this eat call? Yes. So this will not work. This won't work in the first place. Okay, because now you're saying that, okay, I have an object of type bird. I want to store that in a variable of type sparrow. Yes. So by the virtue of saying that s2 is a sparrow, by the virtue of saying that s2 is a variable of type sparrow, I would expect s2 to be able to perform fly, right? But bird cannot perform fly, which is why the compiler will say that, okay, no, this is illegal. You told me to put a bird in a sparrow, but I know that a bird cannot do anything that a sparrow can do. There are things that a sparrow can do, but the bird cannot do. So I won't allow you to do this. Does that make sense? Yes. Please explain 773 again. Definitely. So in this particular line, in the b2.fly, we have a bird b2, which is of type sparrow, right? Over here, the object, right, stored in the variable b2 is of type sparrow, but the variable b2 is of type bird. Okay, so basically we mean that the compiler knows that b2 can do anything a bird can do, but that's all the compiler knows. The compiler does not know that b2 can also do anything that a sparrow can do. Does that make sense? So when you try to do b2.fly, the compiler will complain. The compiler will say that, okay, b2 is a bird. B2 is, I mean, it looks like a bird to me. I don't know. You might have given me a sparrow. You might have given me a peacock. I don't know. But you have told me that this is a bird. A bird, not every bird can fly. Kiwi can't fly. Had you given me a kiwi instead of a sparrow, had you given me a kiwi over here, then this fly would not have worked, right? So I would not allow this even on a sparrow. Even though I can see that this is a sparrow, I don't perfectly know. On the runtime, perhaps you will change this sparrow into a kiwi, right? And you will put this into a bird B2. So I can't call this fly over here. Does that make sense? Yes. Yes or no? Sahil is saying, what is the benefit of this? Right? What is the benefit of this? We are studying all these runtime polymorphism and all these funky things. What is the purpose of this? Can't we always say that, okay, sparrow equals to new bird? Can't we always say that sparrow equals to new bird? Well, if we do that, we will be limiting ourselves a lot. So when we move on to the solid principles, once again, we are not going to cover that today, but when we move on to the solid principles, there's one principle called the O principle, right? The open close principle. Right? In this, we discussed that your code should be closed for modification, but open for extension. Okay, your code should be closed for modification but open for extension. Let's take an example. Let's say that we have a class board and it has an int age and it has a void eat. Okay, and I have written a void do something with board. Okay, and this takes a board do. All right, it says print b.h and then b.eat, something like this. Okay, suppose that this is the current code. This code is perfectly fine. Yes, this code is perfectly fine. If tomorrow I come and write class sparrow extends board. Okay, this was the old code. So this was the old code. Okay, and now I'm adding some new code. Okay, if I do this, now should I be able to do something with bird with sparrow? If I'm not able to do that, if runtime polymorphism does not exist, then I won't be able to extend the functionality of a class. Yes, there was a function that should have worked for every bird, but now sparrow is a word and this function does not work on that bird. Yes or no? So in that case, whatever code I had written earlier, I will have to copy this code. I'll have to make another copy of this, which works with a sparrow. Yes or no? So to prevent this, we allow for runtime polymorphism. We say that, okay, you can pass a sparrow in this. Does that make sense? This also allows you to store other things, right? So you can have a list of, let's say, birds in zoo, right? And in this list of birds, you can totally say something like birds in zoo dot add new sparrow, right? Birds in zoo dot add new peacock, birds in zoo dot add new, let's say, kiwi, things like this. If runtime polymorphism was not there, then you could not have written something like this. Does that make sense? So this is the use case of runtime polymorphism. Is this clear, guys? Yes. Cool. Perfect. Now let's get to the last thing. One question that we had over here. Let's suppose that we had the class board, right? And in this we had the int age, and we had the void of eat, print, take it down. And similarly, we had the class sparrow. In this, we had the int, let's say we had the override. Eat and pickworm. If I come over here, if I say sparrow, s equals to new sparrow, and I call s dot eat. Once again, quickly, just a recap, what will this print? What will this print? This will print pickworm. Yes, this will print pickworm. What if I want this to print, inside this, it could be the case that my parent class has defined some interesting behavior. Yes, currently I'm completely overriding that behavior. Yes, currently I'm completely override the parent behavior. Yes. On the other hand, I could perhaps partially want to override it. So let's take another example. Let's say we have a void sleep. Okay. So this will be just be print, let's say, go to sleep. Okay. Now, in Sparrow, perhaps we want to do the following. Before going to sleep, we want to make bed or nest. Okay. And after that, we want to do the same thing that any other bird would have done. Yes. In this case, we will have to go to the parent class. We'll have to copy this and we'll have to write this over here. There's another way that you can do that. You can refer to your parent class. In the child class, you can refer to your parent class by talking about the keyword super. Yes, super means my parent class. Yes, super means my parent class. So you can call super.sleep. That way, you are not completely overriding. You are just extending the behavior of the parent. Does that make sense? So you're saying that, okay, let's first make the bed, but after that, let me call whatever the sleep function my super had. Yes. So now if you call s.sleep, what will this do? This will first print make bed nest, and after that it will print go to sleep. It will print both these things. Yeah, extends both. My bad. I always forget that. Yes, is this clear, guys? The purpose of the super keyword? Yes. Cool. Now we have, as we said, we have a bunch of other things that we can discuss. Things like what are abstract classes, what are interfaces. We were not able to discuss this, unfortunately. Right? How do you cast objects? What is equals function? Right? How do you override the equals function? What is the hash function? All sorts of weird things in object-oriented programming. Right? Things like what is final, what is synchronized. I mean, other things come into the picture as well. Synchronized. Right? All these things related to object-oriented programming or different keywords of Java or things like concurrency. So we won't be able to dive into all of these. If you want to learn more, please feel free to attend more master classes that we are going to have, or feel free to learn these things from our YouTube or join Scalar Academy itself. Cool. So I hope to see you guys in the next class. Till then, bye-bye. Good night.